And you will already have a bunch of grades.
Do you have mine? 'Cause I think I turned it.
Yeah, I got yours.
I didn't really understand the worksheet being meant for like a group
It
project.
is,
so I
but
didn't
just
know
when
what
it says 4 things, just do one.
Okay, I
So-
have it at home. I
Okay,
just need to
yeah,
put it in.
so just do like one thing, okay? Yeah, because it was meant as a group thing, and we did kind of break up into groups in class, but we're just adjusting for those of you that couldn't be here in person. So just do one thing. And it was meant for like the group to fill out together, so each person would have done like one section. So you just do one section, okay? Then let me look up, see what else I've got in there. And then the question, Alyssa, what's your personal definition of information? That's how we started the last class when we built our binary device. We wanted to know what information was, and we talked about what our definitions of that were. When you go in, you can see everybody else's response, and if you just want to add one to that. And then we built a device, which if you go up to the next link, it says binary message devices. You can click, I gave you a link that takes you directly to that unit in Code Studio. And there's a worksheet with that. And you didn't build one with a group. So what I would like for you to do eventually, maybe if you have time over the weekend or sometime next week, we had things like, I gave them balloons, flashlights, and some pipe cleaners. You need to build a device that you can send a message from one side of the room to the other without verbally speaking or writing anything. So like they used a flashlight to turn it on and off to me yes or no. It's a question that you ask that has 2 responses. And then in the worksheet, it has you elaborate on what if you can't see each other. Then what would you do? So we talked about the challenges and stuff and sending information from point A to point B. And then if you needed more than 2 responses, how could you innovate your device? So kind of think about that and build. You don't necessarily have to physically build something, but just in your head kind of come up with something that you could describe to me on that worksheet. Okay. Then, and for those of you that were here that actually built something with your partner, then just kind of use that worksheet to reflect on what you did and answer those questions, okay? Okay, so I want to show you this little video real quick to follow up with what we did when we built those devices. And Alyssa, it'll make a little bit more sense when you see this video. Okay, so I'm going to play this. This was a video for me to watch as a teacher to try to see what it was going to look like to help prepare me to teach that lesson. I wanted to share it with you so y'all would see what it was supposed to look like. Let me get the volume adjusted. Sometimes I have to trick this thing to make the volume work. I don't know where that came from. By the way.
Beach Boys?
Yeah.
Sending messages back and forth. These devices will communicate binary information, or information that can be represented in 2 possible ways. In order to successfully communicate with their partners, students will need to develop 3 things. First, a question that has a binary response. Second, a device for sending messages. And third, a system for communicating over that device. So you're going to have to come up with your question, you're going to have to come up with your device, and you're going to have to come up with your rules. And you're going to document all of those things. You're going to actually build your device because in a lot of cases you might not just want to use a Slinky, you might want to put stuff together. And then we're going to send messages to one another. While students are choosing their materials, it's really, really important that they think about the fact that they're going to have to deal with different situations in terms of physical setup. So right now they'll be able to see one another, but later on there will be obstacles. So they need to be considerate of that fact while they're making this initial selection. Both partners who build the device have to agree on the rules for how to use it in order to send their messages.
Yeah, you want to test it?
Sure, let's do it.
This lesson explores the CS Principles' big ideas of creativity and abstraction. These physical devices will be built out of miscellaneous supplies like flashlights, cups and string, slinkies, and whistles. As students work on their device,
That's what I
you should
forgot. I
challenge
didn't have
them to
anything
handle
that made
different
noise.
systems.
I gotta,
For example, if
update
students
my
build a
inventory.
device like this one that depends on both partners being able to see each other, then it won't work if the two are separated by putting one of them around the corner and out of view. As students test their devices under different conditions, they'll need to update their rules and the physical system itself in order to deal with the new conditions. Some students might realize that their devices actually have more than two possible states, which is why it becomes really important that they have clear instructions for using the device. For example, if a group uses cups and string to build a traditional telephone setup, then there are way more than two possible conditions of the device. One set of rules might have you tug the cord while your partner waits to feel for the tugs, and another set of rules for the exact same device could instruct you to tap the cup or pluck the string while your partner listens for the taps or plucks. The rules might not always be obvious, so make sure your students are really clear about how they expect the devices to be used.
You should have written down with your partner what your question is and what your two possible responses are. And then you should also write down the rules for using your device.
Students should focus here on the fact that the same device can be used to answer any binary question. The goal is to have not a purpose-built tool that's only useful for answering one thing, but instead something that can abstract out and standardize different signals for answers A and B. This way, the meaning of answer A or the meaning of answer B could change, but the device is still generally useful. For a more complex system, we can think about how to combine two possible states of our device in order to represent even more things. If we go back to the flashlight example from before, then our two states are the light on or the light off. But we can represent way more than two things by combining sequences of on and off. For devices that truly have two states, like a flashlight, it can be challenging to send a sequence of the same state over and over again. For example, if a student wants to send a sequence of 5 consecutive off states, how does the recipient know when one ends and the next one starts? This problem is foreshadowing of the binary number system and the binary representation of information. The devices simulate a really basic version of the physical system that real electronic and digital gadgets use for communication every day. We'll learn a lot more about how those work soon.
okay, so what I wanted you to really get out of that too, and I was trying to make the reference to it Tuesday when we did the activity about the flashlight and the states, and when she was saying to have more than two answers, instead of like yes being the flashlight on and no being the flashlight off, if you needed a different answer choice, like she said, you could come up with something with sequences like on, two offs, on means another answer, right? But how do you know how long the pause is for it to be off? So you know how many offs to count. On is easier, but off is harder to figure out. But if all you had was a flashlight to relay that message, then you could have some challenges there. So when we go into the internet simulator today, that's where you're gonna understand some of those challenges. And when we're talking about rules, that you had to come up with rules for your device, that is also known as protocol. Let me turn my camera around real quick so I can discuss this. I don't have a filmer today, so I wanted to point this out because this is what we're supposed to get out of today. You're going to be able to develop a protocol, which is just that set of rules for exchanging a binary message in two directions. We talked about what binary was already, so that's why I underlined it. So you're going to have to be able to synchronize and coordinate. We're going to talk about or figure out how to calculate a bit rate, and we're going to talk about what a bit is. Okay? So let me get this next video up because I actually had to do this lesson in class myself when I went to training this summer. And it was very confusing because we did not have the video first. So I want you to have the benefit of seeing the video and understanding a little bit more about how the internet simulator works, because it was not fun if you had no prior knowledge of this machine and how it works. And we may run out of time to actually go all the way through the internet simulator today. And this is something you have to have at least 2 people for to operate in the Code Studio part that I gave you the link to. So you may need to coordinate with somebody today before you leave. Set up a time, sometime before next Tuesday. I want y'all to all have had experience with this. So set up a time that y'all can both agree to get on the internet because you're gonna have to join a room together to be able to do this. It won't work without a partner, okay? So it'll make more sense after you see this video. This explains a little bit more about the internet simulator, how it works. Do we have volume this time? Okay, let me trick the volume again.
It's how much to it by.
It's turned down. I don't know how it went down by itself. I don't think I did that.
My name is Tess Winlock. I'm a software engineer at Google. Here's a question. How does a picture, text message, or email get sent from one device to another? It isn't magic. It's the internet, a tangible, physical system that was made to move information. The internet is a lot like the postal service, but the physical stuff that gets sent is a little bit different. Instead of like boxes and envelopes, the internet ships binary information. Information is made of bits. A bit can be described as any pair of opposites, on or off, yes or no. We typically use a 1 meaning on or a 0 meaning off. Because a bit has 2 possible states, we call it binary code. 8 bits strung together makes 1 byte. 1,000 bytes all together is a kilobyte. 1,000 kilobytes is a megabyte. A song is typically encoded using about 3 to 4 megabytes. It doesn't matter if it's a picture, a video, or a song, everything on the internet is represented and sent around as bits. These are the atoms of information. But it's not like we're physically sending ones and zeros from one place to another, one person to another. So what is the physical stuff that actually gets sent over the wires and the airwaves? Well, let's look at a small example here of how humans can physically communicate to send a single bit of information from one place to another. So say that we could turn on a light for a 1 or off for a 0, or use beeps, or similar sort of things like Morse code. These methods work, but they're really slow, error-prone, totally dependent upon humans. What we really need is a machine. Throughout history, we've built many systems that can actually send this binary information through different types of physical mediums. Today, we physically send bits by electricity, light, and radio waves. To send a bit via electricity, imagine that you have 2 light bulbs connected by a copper wire. If one device operator turns on the electricity, then the light bulb lights up. No electricity, no light. If the operators on both ends agree that light on means 1 and light off means 0, then we have a system for sending bits of information from one person to another using electricity. We have kind of a small problem. If you need to send a 0 like 5 times in a row, well, how can you do that in such a way that either person can actually count the number of zeros? Well, the solution is to introduce a clock or a timer. The operators can agree that the sender will send 1 bit per second, and the receiver will sit down and record every single second and see what's on the line. To send 5 zeros in a row, you just turn off the light. Wait 5 seconds, the person on the other end of the line will write down all 5 seconds. 5 ones in a row, switch it on. 5 seconds, write down every second. Obviously, we'd like to send things a little bit faster than 1 bit per second, so we need to increase our bandwidth, the maximum transmission capacity of a device. Bandwidth is measured by bit rate, which is the number of bits that we can actually send over a given period of time, usually measured in seconds. A different measure of speed is the latency, or the amount of time it takes for 1 bit to travel from one place to another, from the source to the requesting device. In our human analogy, 1 bit per second was pretty fast, but kind of hard for a human to keep up with. So let's say that you want to actually download a 3 megabyte song in like 3 seconds. At 8 million bits per megabyte, that means a bit rate of about 8 million bits per second. Obviously, humans can't send or receive 8 million bits per second, but a machine can do that just fine. But now there's also a question of what sort of cable to send these messages over and how far the signals can go. With an Ethernet wire, the kind that you find in your home or office or school, you see measurable signal loss or interference over just a few hundred feet. For the internet to work all around the world, we need to have an alternative method to send bits really long distances. we're talking like across oceans. So what else can we use? Well, what do we know that moves a lot faster than just like electricity through a wire? Light. We can actually send bits as light beams from one place to another using a fiber optic cable. A fiber optic cable is a thread of glass engineered to reflect light. When you send a beam of light down the cable, light bounces up and down the length of the cable until it is received on the other end. Depending on the bounce angle, we can actually send multiple bits simultaneously, all of them traveling at the speed of light. So fiber is really, really fast. But more importantly, the signal doesn't really degrade over long distances. This is how you can go hundreds of miles without signal loss. This is why we use fiber optic cables across the ocean floors to connect one continent to another. In 2008, there was a cable that was actually cut near Alexandria, Egypt, which really interrupted the internet for most of the Middle East and India. So we take this internet thing for granted, but it's really a pretty fragile physical system. And fiber is awesome, but it's also really expensive and hard to work with. For most purposes, you're gonna find copper cable. But how do we move things without wires? How do we send things wirelessly? Wireless bit sending machines typically use a radio signal to send bits from one place to another. The machines have to actually translate the ones and zeros into radio waves of different frequencies. The receiving machines reverse the process and convert it back into binary on your computer. So wireless has made our internet mobile, but a radio signal doesn't travel all that far before it completely gets garbled. This is why you can't really pick up a Los Angeles radio station in Chicago. As great as wireless is, today it still relies on the wired internet. If you're in a coffee shop using Wi-Fi, then the bits get sent through this wireless router and then are transferred to the physical wire that travel the really long distances of the internet. The physical method for sending bits may change in the future, whether it's lasers sent between satellites or radio waves from balloons or drones, but the underlying binary representation of information and the protocols for sending that information and receiving that information have pretty much stayed the same. Everything on the internet, whether it's words, emails, images, cat videos, puppy videos, all come down to these ones and zeros being delivered by electronic pulses, light beams, radio waves, and lots of them.
Okay, so like I said, the main thing you want to think about there is the protocol, is timing, because you're going to need that when you go to this. And there's a continue button. I'll go back to this. Okay, so when you go, I gave you the link that when you click on it in Google Classroom, it should take you straight to this page. And you can start trying it now in class. We can go in and, okay, so you should, when you go, are y'all on there? Do you see my name, this section? I don't know, this is, I may have to set something up for this actually. I don't know what it looks like from y'all's side. Let me see something. Let me go in as a student and see if that makes a difference. I think when y'all go in, it looks like this maybe to begin with. Come up on the screen. Okay, so you'll have the vocabulary words that they talked about in that video. And by the way, before this video, and since I did the training this summer and learned more about this class myself, I understand these things a whole lot better now. I'd heard all these words before. We all had heard what bandwidth was and stuff, but I'd never had it explained to me quite like that. I've read a dictionary definition or whatever, but it makes a lot more sense now, so I hope it does for you too. But then after you're done looking over the stuff on this page, you go to continue, and it should say this, and after you read through that, that's when it should take you to let you pick a room. But I don't know what your side looks like, so that's what I need to see.
It looks just like that.
So, okay, but you can see where other people,
Or,
so you can send somebody a message to connect with you and accept it. So I won't be able to demonstrate this part because I am not in the same place y'all are. Unless, let's see. Okay, there I am. Okay. But I think we have,
Disconnected from me.
well, we'll have an odd number of people today. So, okay, Jackson, I'll accept you. Okay, so you can see me and Jackson up here, right? So the way this works is we can only send A's or B's to each other, okay? So basically, we would come up with a question to know that A is yes and B is no, or whatever. But it says, develop, document, and test a protocol that allows you to use Internet Simulator to relay a message. See the worksheet for more detailed instructions. That worksheet was on that very first page, and I think, no, I did not attach it for you. So, that worksheet will get you a little bit more help. So I'm gonna back up real quick, Jackson.
That's fine.
If it disconnects us, I'll get back on in a minute. This worksheet. So if you go back to this very first page that it sent you to, then you've got this worksheet that will give you directions. And so I said we may run out of time and you may actually have to practice the internet protocol with someone else. So you may want to like pick a time to go in and join each other or something, whether it's after school today or, you know, sometime before next Tuesday. I just want everybody to have some practice with this before next Tuesday. But whoever you work with, and y'all can share this with each other, you can open it and send each other an invitation as a Google Doc, so you can both type on the same thing. I don't care how you do it. But then I want y'all to fill in this as far as how it works. And Jackson, I can get Peyton, he's at a field leadership thing, but I could get Peyton to pair up with you later or something.
Okay.
Yes.
Is that on Classroom?
Yes. You go to Google Classroom, the link takes you, no, this is not. But when you click on the link in Google Classroom and it takes you to this page, it's right there under resources. Okay?
How do you write a question in here?
You don't. You come up with a question and you just pretend you have a question.
Okay.
Okay, so you and your partner would discuss it, and like I said, it may, on that form, you could share it with them as a
Right.
Google form, so you can both talk on there. But then, so if you and Nathan are connected, then basically, if you are the sender,
Mm-hmm.
then you type in A or B,
Oh, okay.
okay? And then you set the wire, and then
Right.
he has to know when to read it. Okay, here's the other tricky part to that. Let me get back and see if I'm still connected to Jackson. So that's gonna work. All the markers disappeared this summer to the smart boards and business department, so we can't orient it, actually use it.
It's trying.
Yeah. Okay, so let me see. All right, Jackson. Thank you. Okay, so this other tab that says My Device, that is gonna be your lifesaver. I'm not gonna tell you any more about it. But that is gonna help you when you come up with your protocol. You need to figure out a little bit more about that little device right there. So, what do you think, instead of, I don't wanna give you the answers, what do you think you could use that for?
Slow it down, like so you're able to read it more clearly.
Okay,
Like track them or
okay. So,
You,
if I wanted to send an A, and I put an A in there and I set the wire to A, every time he reads it, it's still gonna say A until I send something else. So he's got to know when to read it. So that's like your timer. So you gotta figure out, you come up with a protocol with your person, how many pulses before you send another message. So are you gonna send a message in one pulse and then read it in the next pulse? Send a message, read a message. That's what you gotta come up with your protocol. Okay, so use that worksheet to guide you. Like I said, connect with somebody. If you have time to play with it before the bell rings. But if not, kind of set a time later that y'all can connect sometime between now and Tuesday. And I wanted to also show you, we won't have time to watch it. I don't think we only have 5 minutes. I don't know how long it is. I don't want to just kill you with videos today. But this flashlight thing will also, if you watch it, you have time to watch this before, actually, it's not a video, I forgot, it's a thing, so, let's see. I think this will help it make more sense too. Except technology is not working very well for me right now because it's not loading. But if you go through that slides of the flashlight thing, that's gonna make a little more sense to you too. So on their flashlight protocol, they said that A meant it was on and B meant it was off. So test 1, it says, see if you can record the binary signal being set. And then click when ready, but I don't think it's gonna work unless I'm in slide mode. And it's not, yay, okay. So just watch this and let's see if we can record what it's saying. Okay, so you're gonna have to practice with that some to kind of,
Are each one of those lines a bit?
yes.
It's 2 A's and a B.
Oh, I meant the little tick.
No, I don't think so. I think each
Okay.
rectangle shape is a bit. But see, there was one that was longer too, so I don't know.
Yeah, we'd have to know
Mm-hmm.
what the time
Huh.
span is. or whatever.
You can see right there, that one was longer. Okay. So, I don't know that I have any answers, but let's just kind of see what these look like. Yeah, I'm wondering if the dots do represent bits, but that'd be a lot of bits to have to record.
A byte is a lot of bits to record. So I mean, that's not a lot compared to that.
Okay, yeah, I haven't looked at this. This was not something they exposed us to this summer, so I haven't got to play with that just yet. I guess it's only 5 slides. So anyway, look at everything in this lesson 3. After you have gone through and done the internet simulator, there are some questions. And also back, that's another thing I forgot to tell you. In Google Classroom, I gave you the link to the last, I feel like I'm throwing a million things at y'all at one time, sorry. But when we did this, binary message devices, and I gave you the link to that, to Unit 2, or not Unit, Chapter 2. In this one, after we did our device, it's got some questions for review afterwards for you to reflect. So after the worksheet, after you turn that into Google Classroom, then,
Do we just turn in the worksheets and have it done? Because there's more than one challenge, and in here we only did the first challenge.
right, think about, pretend that we did more. So in your mind, just do them in your mind.
Okay.
But on here, after you go past, go back to that one, the 2 bubble, and go through and answer these questions. Don't look at the answer, don't look at the answer. And then you submit it, and it'll do that. And then it gives you more questions, okay? And it's being really slow. But go through and answer those questions, because when I look at my side, I'm gonna show you what my homepage looks like if it ever will cooperate. I don't know what's going on with internet today. Could be that I have a million tabs open.
And then you're using Internet Explorer.
Yes, I know. Hayden gets onto me all the time. Anyway, it shows me your progress. So I need you going through answering those questions too. So I know that we're done with that section, okay? Thank you guys. I know it's a lot at once, and I'm flexible on this, so just do the best you can with it.